Hello, everyone. I'm Siva Radhakrishnan. I'm a principal engineer here at Forward Networks. And over the last 5+ years at Forward, I've spent a lot of time not only on the technological improvements in the platform itself, but also interacting with a lot of customers, trying to understand their use cases and workflows. And in this session, I'm going to walk you through a variety of use cases that we heard from our customers firsthand. Right, so you're going to see a demo. You saw a little demo of the path analysis feature, and you'll see how our customers are really able to leverage this not only through our UI, but also through a variety of APIs. Right, so let's dive into a few of these different use cases. I'll walk you through them one by one. So the first use case is what I call a path checking use case. So this is something that came to us from a financial enterprise. So they operate a network of 5,000+ devices, network devices, and they run hundreds of applications in this network that are constantly evolving. Right? And the network team would frequently get asked this question, is this network ready for an application deployment? So what does this mean? So an application essentially translates to a set of source IP and destination IP pairs, possibly with port numbers or protocols. Right? So basically an application traffic flow tuple. And you can have essentially each application is characterized by a set of these flow tuples that need to be satisfied. This represents all the dependencies on all the traffic flows that need to be satisfied or available in the network for this application to function successfully. Right? So they had this requirement or this question come up so frequently that they actually built a service to make it easier for their network engineers and operators to answer this question. And over time, as you can imagine, they're operating a huge network with a wide variety of different vendors. This network has organically grown over time. It became pretty much a management nightmare for them to keep up with a variety of network vendors and devices and be able to support all the variety of protocols that are actually running in this network. Right? And that's where they came to us and said, this is what you do. Right? So why don't you make this happen for us? Right? So what they did was basically use our platform, Forward APIs, and the path search APIs to kind of build upon this functionality and be able to answer these questions in a really fast manner. Right? So this is a use case that we saw initially from this one financial enterprise, but over time we've seen this similar use cases at a lot of different organizations. So the next use case is what I'm going to call an app team self-service use case. So the same financial enterprise that originally built out this application for the path checker, they came to us and said, there's all of this information that we are basically exposing to our network engineers. Why not expose this directly to our application developers? Right? Our app owners keep asking us for this, the same question again and again. Does the network provide the expected connectivity? Right? And they wanted to avoid the need for the network team or the network engineers to be involved in answering every one of these requests. So they wanted to provide a means for the application owners to essentially help themselves. Right? So we'll take a deep dive into this particular use case, and you'll also see a little bit of a demo later in this session. So the next use case is one called continuous network verification. So this is an application that came to us from an ISP this is a large service provider who was deploying an OpenFlow-based software-defined network. Right? So they wanted to essentially verify that the reachability policies that were defined by the operator were correctly implemented in the network. This was an entirely new stack of components that we're building on top of. Right? So they had a policy controller, a network management system, an SDN controller, white box switches. All of these components need to work in concert, do the right thing at the right time for this network to essentially satisfy the policies that the operator wants to implement in the network. Right? And they wanted to essentially enable this kind of a continuous verification workflow where through APIs they can verify that the policy is being met, and if the policy is violated at any point of time, they get an immediate notification. Right? So this was an unfamiliar environment where traditional tools like traceroute just don't work. Right? So if you're using an OpenFlow network, you're operating at layer 2, where OpenFlow, the white box basically uses OpenFlow rules to forward traffic. It's not going to respond to simple traceroute and ICMPs. Right? Similarly, the devices don't have a well-defined CLI. They often operate with binary protocols to kind of get messages from the controller and program the devices itself. Right? So they wanted to essentially leverage the Forward platform to get this kind of a unified view across all their devices to kind of perform this continuous verification in this network. So the next use case I'm going to talk about is one of automated provisioning. So this use case came to us from a large financial services firm. So they operate a network of 15,000 plus network devices. They have hundreds or even thousands of applications that are running in this huge network. And from time to time, they have this request to basically provision new virtual machines, provision compute, and network connectivity for a new application. So this doesn't always have to be a new application. It could also be an existing application that has some new dependencies, and you need to provision new traffic flows through the network to establish connectivity. Right? So they wanted to automate this entire process of provisioning both compute resources and network connectivity for these applications. So automating the provisioning of compute was something they already had built, but they didn't have an easy way to automate network connectivity. So to automate the provisioning of network connectivity, the key questions you need to answer are, do any network routes need to be updated to support this application? Are there new endpoints that need to be able to talk to each other? And the next part here is which firewalls along the path actually need to be updated to support this traffic. Right? So note that there is a clear distinction between basic reachability of forwarding and routing functionality in the network and the firewall or security policies. Quite often, you even have different teams managing these two policies. Right? So for this particular automation workflow, one of the key metrics that was very important for them was performance. Right? As you can imagine, if you want to automate this entire workflow, an application is defined by thousands or even tens of thousands of these flow tuples, all of which need to be verified, for which you need to validate this connectivity and identify any firewall rules that need to be updated. Right? And we learned from them that we need to support a very high query processing rate of hundreds of queries per second to be able to quickly provision the network connectivity. Right? So one thing we actually learned was exposing a bulk search capability was actually very beneficial for them because for our users, because they were able to express this application requirements as one batch of requests. So these are the set of flow tuples for which I want to provision connectivity. But the interesting bit here is because all of these requests were provided to us as a batch, we were able to leverage this information to kind of avoid essentially reuse computation across these requests, thereby improving the query processing rate even further. Right. So the next use case here is one that I call an application-specific debugging view. So this use case came to us from a media company that they essentially wanted a way to diagnose application-specific performance problems. Right? So they already had an NPM tool, a network performance monitoring tool that was deployed in their network. But they had no easy way to kind of correlate the performance counters and performance information or health information for different links and devices in this network with the applications that would actually be impacted by those counters. Right? So essentially, if you have the performance metrics for every device and interface in your network, how do you quickly identify which interfaces or devices are relevant for a particular application? So that's where Forward was able to really fit in and they were able to correlate this information. We'll take a little bit of a sneak peek at how they built this application out in a little bit.
So you're talking about application-specific views and lots of stuff around an application, but all the stuff that we've seen so far has been based off of L4 type filtering.
Yes.
Does the product understand like next generation firewall, pick your terminology you want to use there, right? So, hey, I'm going to be fine through all the L4 filtering, but we're going to trigger the IPS, and this traffic's going to be whatever the next gen firewall is going to decide to do to it.
That's a great question. So we've recently added support for some of the layer 7 protocols and firewalls that do kind of deep packet inspection. There's limited, but recent support that we're gradually adding to. Right? So layer 1 through 4, we model everything, but layer 7 and above, it's a lot harder.
Yes.
It's harder to make sense of, but yeah, that's something that we're actively adding support for. We recently added support for this for one of our users.
So, if you were to run this kind of scenario through your product, does it go, hey, we're not really sure, or does it give you kind of a false report saying it's dropped or it's passed, or does it say, hey, it could be
Today, it would model both behaviors. It'll say this path can get through, but then it'll say under these conditions, if you have this application, it's going to get through. So if you're not running this application, it would be dropped. So that's the kind of information that we would expose to the user. The last use case that I'm going to talk about here is a closed loop automation plus verification use case. So we looked at automated provisioning, but to really close the loop with automation, you also need verification. You want to verify that the automation system that you're building is actually implementing the expected changes in the network. You want to verify before you make the change and after you make the change that you actually had the desired impact on the network. So this is a use case where essentially you can use any orchestration system like Ansible, NSO, or any custom orchestration system to push out changes to your network itself, to kind of automate the process of pushing out changes. But you also want to validate that the changes have the desired effect on your network and they don't have any unintended consequences. So that's where Forward can really help close that loop and enable this closed loop automation and verification system.
So if we made a configuration change and then we had to re-snapshot our network, and that takes an hour, potentially, or some amount of time, it's a closed loop process, but we would have to budget that kind of planning of taking that amount of time to
So that's a great question. So if you think of how you deploy these changes, you're typically touching a few devices at a time, right? So you're not pushing out a change across your entire network. You're touching a few devices at a time, and that's where the partial collection and partial refresh capability really fits in, right? So if you know the set of devices you're actually going to update, you can just refresh that set of devices, which really drives down this collection time.
But if you're changing something like route maps or routing policy that would, okay, maybe I'm only changing 2 or 3 routers, but I expect a very broad impact of that change, then we'd have to go and collect.
Absolutely, you're absolutely right. So if you know the perimeter or the kind of the blast radius of your change, then you know upfront like which devices need to be refreshed. Otherwise, you would have to collect from the entire network.
All of them, yeah.
And that's part of the reason why we're really trying to drive down this total collection time to something that you wouldn't even notice.
Which is why I asked, could I just pick and choose the protocols I want to collect? Because if I knew, if I only cared about these 3 or 4 protocols, I would just do those for right now, and then let the evening run collect everything.
Yeah, good question, good feedback. Yeah.
So I have one more question about that. Is there a way to tell Forward Networks, this is the intent of my change? Like I intend to add a BGP peer here and a BGP peer there without making the change. And then I have some configuration. Maybe it's on the CLI, maybe they do it via the CLI, or maybe they do some configuration change elsewhere. But it's done. And then Forward says, yes, the change that maybe you did manually, it is actually running the way that you expect. Like I want to pre-provision intents into Forward.
That's a great question. So we do support kind of, I wouldn't call it pre-provisioning, but kind of a predictive analysis in specific use cases with firewalls and load balancers. You'll see a little demo of that in the next session, where you can actually do pre-change validation for firewalls and load balancers, and then post-change validation across your entire network.
I think I might be able to answer the question a little differently. I think you were asking about state changes coming from routing changes. Is that correct?
That's one of them, yeah.
Or simulation, right?
Yeah.
Simulation of a change, right?
So to do checks upon the current state of the network, actually, in Nikhil's demo, he's going to talk a bit about Network Query Engine. That was our focus at Barcelona, and that's a way of taking the data that we've got and making it accessible so you can say, after I did my collection, are those routes that I expect to see actually present? So this is actually, what you're describing is one of the motivating cases for the Network Query Engine we've built, and you're going to hear more about it soon.
Okay, all right, great, thank you.
Cool, so we looked at this a variety of different use cases here, and I want to mention that these aren't just ideas at this point. We've gone through several rounds of iterations with kind of refining the APIs as well as making product improvements to get this to a point where this is deployable in production, and it is deployed in production at a variety of different organizations. So these first 3 use cases that you see here, they've all been deployed in production for several years now at a variety of different organizations. The next use case for automated provisioning, this is actively being deployed as we speak, so at a large financial enterprise. And we are seeing a lot of interest for similar use cases from other organizations as well. And these last two use cases of the application-specific view and automated verification, automation, the closed-loop automation and verification, is again something that we are actively testing with our customers and trying to get their feedback, trying to see how we can get this deployed with them.
So you've got the chatbot 1.5 years in. I'm curious, have you gone back to the customer and said, how has this changed your business? Like, have you saved money? Is the network more reactive to the end users who are using the self-service? Or like, how has it meaningfully changed, their business value? Once they put the system in and they've got the self-service portal, that isn't to benefit the network engineers, it's to benefit the app people.
The app owners.
Which is huge. So I'm
Absolutely.
curious if you guys have been collecting that level of business value metric, because I think that's where the real gold is.
Yeah, so there's kind of two aspects to this. One is the app owners kind of don't have to depend on these network engineers to answer every question. So that's kind of the key aspect. And it also kind of gives them a level of appreciation of what the network engineers are having to deal with. Right? So when this information is exposed to them, not with the entire complexity, but just the basic information that the app owners, app developers understand in terms of networking, they get a better appreciation for what the network engineers are actually having to deal with.
Yeah, but in terms of like concrete, meaning like a customer says, our app engineers were delayed a month because, because the network was, the network guys didn't do their job or took too long, whatever. And now that they have this kind of self-service portal, it's like, they've been able to deliver apps faster, which means they can make more money for the business, et cetera, et cetera. Like those real meaningful, concrete business value dollars. Like, have you gotten those specific stories?
Yeah, so we've heard a few examples similar to that where the app owners say that they didn't have to contact the network engineers at all because their app was working. Or in cases where the network was not working, they knew exactly why it was not working, or they could contact either the network team or the security team. Right? And that basically enables them to get quick answers to, is my network ready right now for me to deploy this application? Right? So that basically helps them turn around the time to deploy these applications much faster.
I think what Jeremy's asking, though, is there any actual ROI numbers based off of either utilization of people or based off of...
like the VP of that app team, like did he come and say, you guys just saved me $3 million or help me make another $30 million that I would have opportunistically lost?
Can I take that question?
Yeah,
so we don't have a quantitative number for that yet, but we are actively speaking with this customer very close to us. So and we are trying to bring up the numbers, but qualitatively we've heard amazing things. Both that has helped both the application team developers because they don't have to depend on the network team anymore, and the network team, the network engineers themselves, because they don't have to waste their time answering these questions day in day out.
Yeah,
but this is qualitative feedback.
Yeah, this gets back to the core fundamental. I think to Jeremy's point is like there's great things that you can do for your employees. Like if we had like nonstop, like you bought my house, you let me live there, you let me do all that. Like those are great things, but they don't mean anything from a business value perspective. And I think what his point is like you need to show the business value perspective to say like, hey, we should invest here because we're going to make X times multiplier over there out of benefit for this team. And they should see these dollars. That's what the investment is to go invest in something like Forward Networks because there's a direct one-to-one correlation of this value dollar metric above what we're already doing today. I think that's really
huge.
Yeah, that's huge because that allows you to go out and go to the application team and say, you should go buy this for your network team.
That's right. That's right. That's
the
right.
discussion you want to have. You don't want to have the network team come ask for it. You want to go to the app team and sell it that way.
Yeah.
Yeah. No, we've actually heard. Is this on?
Yeah.
We've heard anecdotal evidence from our customers, and we've also gotten some real quantifiable analysis. So we actually have an ROI case study that's published on the website with one of our big customers, and we're in the process of doing another one right now. But we even had a customer last week tell us that they were able to reduce the number of P1 and P2 outages by 50% since deployment. So we've got some metrics, and we're actually working with an industry analyst right now to quantify some of that and write it up in something that's meaningful to customers and network admins who deal with this stuff every day.
Yeah, because I think to his point, while it's great for a network team, almost none of them have budget to drop to do this unless they have very forward-thinking CIO, CTO level folks that are saying, like, I understand what the use case is, I understand where I'm going to get value and benefit later. But if you go to most network teams, they're like, that's great, but I can barely afford my refresh for my for my my maintenance costs. So like adding something on top, unless I get something else for another business unit, it's unlikely I'm going to get it funded. That's probably where you're going, right?
Yeah, well, especially like in this case, the savings offered by the self-service app and the pace with which the business can roll out applications without bothering the network team, that's quantifiable.
Yeah.
So we're working on putting some of those metrics together. We do have one published ROI study though, so far.
Cool.
Thank you.
With that, let's take a quick look at the application-specific view use case that I just mentioned. So this was an application that essentially this large media company came to us with. And they wanted this ability to kind of correlate application-specific performance problems. So they had an NPM tool that they had already deployed. And this turned into a really nice nights and weekends problem kind of deployment with them, with very impressive results. So they built this nice little application where an application owner or a network engineer could essentially provide a source IP and a destination IP. And the application would essentially reach out to the forward application to figure out all the paths that are relevant for this traffic, right, between the source IP and destination IP. And for every device and every interface that's relevant to this traffic, it would also find the network health metrics, performance counters from this NPM tool, right? And that's essentially what you see in this little view here. So that was something that was done a few years back with very little support from us, where they basically said, this is a great use case that I kind of just dreamed up, and I already have this NPM tool that I've deployed, so I would like to integrate, kind of marry the results that are coming out of these two to deliver values to the application owners. So with that, we'll now take a deep dive into the application team self-service use case, and we'll also follow that up with a little demo. So the core requirement that we heard from this financial enterprise was they wanted to remove the need for that network team to be involved in answering every single network connectivity question. So the solution has to be very simple to understand. App owners need just the information that's relevant to them, not the full power and complexity of everything that's available in our forward UI. Right? They also need a solution that integrates well with tools that they're already familiar with their workflows. So this network operator from this enterprise basically told us their developers live on Slack. Right? It's at their fingertips all the time. They love it as a collaboration tool. And they essentially had experience already building chatbots to kind of help app owners. Right? So they said a chatbot would be a really nice way to kind of expose the functionality, path search capability to app owners. Right? And the chatbot also provides a really easy way to decouple access to path information from credentials on the forward platform itself. So you can control access in your own chatbot. You don't need to have, so every application developer that has access to this path search information doesn't need credentials on the forward platform itself. So let's take a really quick look at how a chatbot works. So you have Slack, which is basically a service that's in the public internet. And you have a user that's trying to connect, that basically connects to Slack, or either using a browser or a desktop or mobile app. Right? And there is a bot, a chat bot, which is essentially a service that is registered with Slack. And in this case, so the service needs to be registered with Slack, and they also share a secret key which they can use to verify that requests are actually coming from each other. So when the user enters essentially sends a message that is addressed to this chatbot, Slack sends the message over to the bot, and the bot is essentially free to do what it wants with it. It can post messages, post responses, or trigger other operations in the background. It can essentially trigger any operation. It gets essentially a stream of events from the Slack service. So in this case, the bot is essentially going to contact the forward server and provide path analysis results to the user. So with that background, let's switch to a quick demo. All right, so we have this channel here on Slack where the forward bot has already been added to this channel. And as an application owner, I can basically converse with this chatbot. All right, so let's take a quick look here. I can query the bot to get a list of commands that it supports. So in this case, it's very simple. It's a demo. It supports a path command and a locate command. Right? So we'll dive into examples of each of these. Right? So let's say, as an application owner, I have this application where I want to add a new dependency. Right? I want access to a mail server so that because I want to send out email notifications to users. Right? So to provision this, essentially what I'm going to do is I'm going to query the chatbot to see if this connectivity already exists, and we'll see what we get. Right? So I'm just going to copy over the example from here. So what this command represents is basically it's asking for paths from this source IP address, which corresponds to my application, to the source destination IP address that corresponds to a mail server. So essentially, immediately as soon as I enter this query, I get a list of results. So what you see here is essentially a path from the source to the destination. So I, as an app owner, all I know is there are these two IP addresses. I have no idea what network devices this traffic is actually traversing, what might be blocking it. But I get an immediate answer here in terms of where the traffic is flowing through this network. Right? So the first thing you see is there are two key outcomes here that we distinguish between. One is the forwarding outcome, which basically says, is there basic forwarding and routing, is that configured well enough in the network to basically provide this connectivity? And the security outcome basically says, are there firewalls along the path that permit or deny this traffic? Right? So if you look at this query, so you see that traffic originates at an NSX device in San Jose. It moves from San Jose to this firewall in the San Jose data center, where it's actually getting dropped. Right? For each hop, you know the ingress interface and egress interface, and you see that it's actually being blocked by this firewall. But we don't stop there. Right? So that's where a trace route would stop. Right? So this is basically an application. Because we're doing this in software, we're able to trace it past that firewall drop. We see that traffic goes from San Jose to Atlanta, where it would also be blocked by a firewall in Atlanta. We've identified that there are two firewalls that are actually blocking this traffic. And finally, it goes from Atlanta to AWS, and it gets delivered to the mail server that's residing in AWS.
Question.
Right? Yep.
Is this information coming off of the model that you've created, or is this coming from the you're actually probing the network in some fashion?
It's entirely coming off from the model.
Okay.
Yeah.
So I've got a question for you on that. If you've got global data centers and you're doing application delivery across multiple data centers and you've built the model of the network, and as you're planning this because the application team wants to build something to a certain path, and the operational state of the network has changed because we've lost a route and now this application is being delivered out of another data center, how do you account for that?
So that's a great question. So today, the way we deal with this is basically we try to drive down the time to actually collect and refresh this data. That's where we're moving towards.
Okay.
Right? So today, we are at a point where you have data that's on the order of a few minutes, a few hours back. Right?
Okay.
So having access to this data in the hands of your application developers is crucial. Right?
Okay.
So
this would be a few hours behind. Like this is what we're looking at would be a few
minutes
hours
to
old,
few hours,
Okay,
depending
so
on,
we're not talking about terribly old data here.
It's not going to be days.
Not very static for like weeks or months or anything.
Absolutely
like that.
not.
Okay, gotcha.
Yeah. So most of our production deployments, they either refresh this every day or several times a day.
Okay.
So I want to jump in for a sec. The median time for our largest collections to collect all of the configuration state from devices is less than 30 seconds.
Okay.
So if you've got relatively recent devices that don't have weak little wimpy CPUs, and they're not all facing the internet, and you're willing to provision a TACAC server that isn't wimpy as well, then you can do all of this in parallel and drive that time to where it's on the order of a minute or minutes.
Gotcha.
So it really depends on the equipment that you've got. And of course, we're looking at interfaces in the future that'll drive that time to zero.
Okay.
Things like streaming telemetry.
That prompts a follow-up question. Do you ever run afoul of the security department where you have this massive blast of information
you load
grab where
12,000
they're like, hey, that's maybe not what we want? Is that ever a challenge for you guys? Where you're triggering something in security policy where it's looking for that kind of widespread crawl of the network?
All of the accesses are authorized, right? Because it's a user that says, here's my list of devices I want you to go out and get, and here are the credentials for it. And so we actually, I can't think of any instances where that's occurred in the history of the company.
Yeah, but I didn't mean TACX so much. I meant like security, like L7 inspection tools, things like that. Things where you have like security tools that are looking for those kinds of anomalies.
Intrusion prevention and so forth. Yeah.
Okay.
I mean, there's a chance that a subnet scan might trigger that, but that's the only thing that comes.
I've run into it before. That's the only reason I ask. I had it happen in a large enterprise where we triggered a security protocol by a large crawl. That's the reason I ask.
Okay, so this application is used not just by the app owners, it's also used by the network team itself. They get quick answers without having to even access the forward UI. And they also get a quick link right here to access the forward UI. Right, so this is the way to kind of dig into the details of what's happening at each hop along the path.
But they would need to have credentials to get to
Absolutely.
That. Okay.
So this can be exposed just to the to the network team itself. If you're logging in to the chatbot as an application owner, you wouldn't have access to this.
Perfect.
All right, let's take a look at another quick example here. So this is a use case where I want to check for, I have my application here, I have a source IP address, but I want to verify reachability on port 22, essentially SSH traffic to an entire subnet, not just one single IP address. Right? So that is something that we also support, and you get a response here saying that traffic is actually getting through to that subnet. Right? So we have this flexibility in terms of what protocol, you can specify protocols or port numbers to specify where you want, what kind of traffic you're actually looking for.
So another question on that, can you then take that workflow and turn that back around into something like a change control system where the application owner says, okay, I understand what I want now and I understand where the challenges are, where the roadblocks are. Can that go into a workflow that then where you're not having to just copy and paste that out of Slack?
That is exactly right. So this level of visibility tells the app owner that it's the firewalls that need a change, not underlying reachability. Right? So they immediately know, do they need to contact the security team to update the firewalls, or do they need to contact the network team? Right? And I don't have that in this demo, but you can imagine another command that basically creates a ticket in your ticketing system to basically provide this connectivity.
So you can feed the same information into a different command that's going to put it into a workflow.
Exactly.
Cool.
Do you have any customers that are using this to verify security rules, to verify that I don't have Telnet going anywhere? Do you have anybody using it in that type of capacity?
So we have users using it in that capacity as far as the path checker API goes and the UI goes. They have systems to verify that connectivity is either exists or does not exist. These are isolated. That can also be verified. A Slackbot is not the best way for best interface for automation, right? So you can build applications on top to kind of automate that workflow or verify, right? But you can get the same answers through the Slackbot.
Yes, we have customers that are using our product for that kind of security validation, many of which we can't actually reference for kind of obvious reasons.
It's
a good use case.
Can you get, like, does this VLAN exist on this interface type of information? Like if somebody said, I want to know where this VLAN is configured in my network. Does Forward maintain that kind of database? And I mean, that's not as hard as a path computation. I get it, but it's like, people are like, well, where's that VLAN? Or where is it not? You know, that kind of use case.
Absolutely. So why don't we take a really quick look?
Or where's my MAC address? That kind of. Yeah.
In our inventory right here, you'll see a bunch of VLANs right here. So these are all the VLANs that are configured in this network. It shows all the devices where this VLAN is configured. If you click on View Details, it shows you exactly the set of devices where the VLAN is configured.
And does it show like these interfaces are configured to use these particular VLANs?
Here you go. Right. So you can expand this. You'll see every single interface where the VLAN is configured.
That's great. Not as groovy as path computation, but
Is it useful?
yeah, very much.
Probably add it.
Yeah, yeah, great.
All right, so I'm going to show you one other thing real quick with the Slackbot. So besides paths, another thing that this user told us was they would like to be able to just locate an IP address. Where is this IP address in my network? Right? I'm given basically an app owner comes to me and says, this connectivity doesn't exist. Here's an IP address. They spend several minutes just trying to figure out where is this IP address located in their network. Right? And this is something that we can provide immediate answers to. Right? So this is obviously accessible in the UI, but it's also accessible here. Right? So in this case, this is a particular IP address that's inferred to be a host, has this MAC address, and it's located on this switch. Let's take another really quick example where we locate an entire subnet, not just an IP address in this case. So in this case, we search for an entire subnet, not just one single IP address. And I told you a list of different ports where this IP address or the subnet resides. Looking at this, can anyone guess what the subnet represents? Looking at the names and interfaces?
Management.
That's exactly right. So this is the management subnet for the Atlanta data center. Right, so that concludes the Slack demo. And let's switch back to.
Was this you guys mentioned an ROI, I thought, about the team self-service that you were working on. Was that specifically what you guys were talking about, creating an ROI case around that use case?
This particular use case?
Yes, that particular use case.
So we are considering this as one of the use cases, but this is not the only one. Yes.
Right.
Sorry.
Does the product understand overlays, like tunnels, and so understanding where that tunnel is running and how that might traverse through the network, that you could kind of enter the tunnel and teleport? And so
Absolutely.
Is there a way to have a view so that you could see, like,
that is a great question.
here's the traffic as it enters the tunnel, and here's actually where the tunnel paths, and this is where the traffic comes out of the tunnel.
Like
Let's look back at that.
Yeah, exactly.
Yeah, right here. If you see this traffic, you have an overlay, you have an NSX overlay over here, and there's a link right here to view the underlay traffic. Right, so you immediately get an understanding of what's the physical topology, where the underlay traffic is flowing through this network. So it's just a click away. And as you can imagine, this would be pretty crucial for understanding things like performance issues. If your underlay is having performance problems, how do you identify that? You make it very easy to access that information. So we looked at a few different demos and a few different use cases. So one of the core aspects, one of the core features that's really enabling all of this is path search. So I'm going to just quickly show you what our path search API looks like. So at its core, given a source and a destination IP address, it returns a set of relevant paths and the forwarding details at every hop along this path. Right? So we have a well-published API. It's gone through several iterations, and we've really refined it to a point where it's deployed in production at a variety of different organizations. A lot of people are getting value out of this to build their integrations. Right? And all of this is exposed through Swagger documentation. We have detailed documentation describing the request and response formats. So here's a sample request and response. Yeah.
Just a quick question. Is there a time frame or how often do you iterate the API?
So the API keeps evolving. We keep adding features to it, but we maintain backwards compatibility. Right? So that makes sure that, as we add new features, so we often need some flexibility in terms of what kind of results you want to look for. Right? So depending on the use case, as we discover a new use case, a customer might say, I want to look for traffic of this kind. Right? So in those cases, we add support for that. But obviously, your existing API users are going to be unaffected.
So we're always adding.
Exactly. Yeah.
So in terms of your API, most people who have an API say, here's my API, here's all my REST calls, aren't they pretty? And they're colored and they're great. But I have yet to see any company really come out with like a cookbook on this is the order in which you make these calls, and here's how the data is tied together when you're trying to do a complex workflow. Like, maybe you have to call this API before you call this other API, and from that data you call these 3 other APIs. That's what I mean by a cookbook. You guys, have workflows that would require such a cookbook, or not? And if you do have really complex workflows, do you have cookbooks?
That's really good feedback. So by and large, these APIs are independent. The path search API, for example, what you looked at here, each is an independent API. You don't need to, the Slackbot that you saw there, right? So that basically is making one of these API calls and presenting the results, right? So for many workflows, we don't need kind of a detailed sequence of steps that you need to perform, but there are things like, for example, configuring a network. How do you add devices? You need to add credentials first and then add devices, these kind of things, where a cookbook would make a lot of sense.
Yeah.
And yeah, we'll definitely take that as very useful feedback. Right? What you see here is simple JSON request and response. And the request, basically, the only required fields are a source IP and a destination IP. All other fields are optional. And we also have some additional fields to kind of expose this flexibility in terms of, depending on your use case, you might be looking for results of a certain type. Right? So things that are always dropped. You might be looking for security violations. In that case, you're looking for traffic that's getting dropped versus for traffic, for cases where you want to look for traffic that actually gets through. And the response here, I want to just highlight that we expose how, what the source and destination IP addresses, where they were located, how they were located, and a list of paths with the details that I just presented, forwarding outcome, security outcome, and the details for every single hop. So to summarize, we looked at several customer-driven, production-deployed use cases that we see deployed across a range of customers. All of these are enabled by this core path search API. The power of API is that we create a compelling platform, and our users essentially find interesting new ways of leveraging it. In fact, the Slackbot was something that we didn't even hear about initially. And well after they implemented it, they told us that, hey, this is a new way we try to use this platform. You got a sneak preview at the application-specific debugging views. And we took a deep dive with a demo of this self-service Slackbot.